Hello, I am Adam Short, and we'll be presenting the Turin parallel robot for MAE 511 Advanced Dynamics at North Carolina State University. In this analysis, I will be presenting the visual portion of the report by using VPython to show the motion and appearance of the TPR. This Python script definitely took a lot of work to do, but I think, as you will see, the results are very satisfying. 6 degree of freedom parallel robot. In order to accomplish this, needed to set up the environment, and then add some constants. All these are found in the presented paper. Frame vectors are as follows. The MATLAB definitions for things like rotation, position, Euler angles, more position on base plane, position in the end effector plane, and then the various vectors that are derived are initialized, and these are also initialized. Initial link parameters Q1, Q2, which are the angles of links 1 and 2 of the respective bodies, are initialized at 0.5 radians. Now we initialize the bodies. Total of 70 bodies. 66 are robot itself, 22 per leg, with 4 being the points of interest. The observation point, H1, H2, and H3, which affect the observation point. Now here is an example of what comes after. We have links of frame 1. 4 elbows, the location of which are described here. We have the links between the elbows. We have the roof pieces. Same thing for frame 2. Same thing for frame 3, with the respective bodies labeled correctly. Now for run. The z of interest is pegged at 11 to begin with. X at 0, phi 0. We're going to segment each parameter by 0.05 radians and length units. And then we run through this. So all of the things above stated must be updated in a for loop. So we let it run for 2,000 steps at a rate of 200 per second. It'll last obviously 10 seconds, and it'll go through this loop, updating how we change position and orientation. So these are all the MATLAB definitions that update right here, and with the intention of gaining your Q values right here. Then your observation point and your supporting points are updated. Then those Q values just go into here, and the positions for everything is updated. And it'll print end of run at the end. So here we are. Empty slate. What we need is a coordinate system to run everything off of. We're also going to have 3 more here, 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 120 degrees apart. Boom. These are the base points. Boom, boom. Coordinate system is always aligned off of the left one. Let's make some elbows here. The legs, and these are controlled by Q1, Q2. Connect these together. Make the top roof part. And boom, there you have it. 22 pieces in that. Now we can do the same thing with this over here. Boom. There is your working machine. So you can set this thing up doing its own, iteration of the various Q values. So you've got 6 Q values here, but it's more helpful if we do a little inverse kinematics to actually accomplish what we need to accomplish. See here we got, an expanding triangle that's attempting to appear like the end effector in the paper, but actually it's just not very realistic at all. The rotation and the position are just all over the place. So we got to do some hard work to calculate it properly. This is the origin. This is point 1, point 2, point 3. The Q values affect these two legs, Q1 usually being negative, swinging this way, Q2 being positive, swinging this way, because this direction is positive rotation. These are all influenced by these legs, and this prismatic link influenced by the C value that is calculated in the math. These green points are the respective H's, H1, H2, H3, and the end effector point of interest. Now here is some vertical translation up and down along the z-axis. The H stretches a little bit, which is probably something to do with the A, B, C, and alpha, beta, delta parameters not doing their job correctly in the Python script. Yeah, that's a vertical translation. Now here we can see some rotation about the y-axis. There's still a bit more of the stretch. But the point of interest can be placed anywhere inside of about a 5-unit path with about plus or minus 30 degrees of rotation. So, mission accomplished on this simulation.